In this video, we are going to continue our discussion of ES6 classes. So in the last video, we saw the basic semantics of ES6 classes. In this video, we are going to dig deeper into some of the semantics and some of the syntaxes of that. So one of the things which we saw in the last video was a constructor. So we had something like this. So for example, let's say there is a class. Inside that we had something like this, which we called a constructor. Now what is a constructor? A constructor is a special method. So this, as you can see, that this is a method, but this is a special method and the name should always be constructor. Okay, and it is a special method for creating and initializing an object created with a class. So when you create an object from a class, so this S object is created, then this S object is initialized in this constructor only. Okay, so for example, you see that let's say I just print width and it is 5. Actually it is initialized here only. If I comment this, then you can see that it is undefined. In fact, I can remove this altogether, and then also the object will be created. As you can see that S is created, but S dot width is not defined. Okay, but if I create a constructor, then that is initialized properly. So as you can see that this constructor is used for creating and initializing an object created with that class. Now a constructor can also use a keyword called super keyword to call the constructor of the super class. Now what is this super keyword, and how to call it, and what is this super class, these things we have not discussed, but we will discuss it later. Right now I am just putting it here just for the sake of completeness, so that later if you're revising, then you can just have a glance at it. But we'll be considering super and inheritance, etc. in some other video in the classes. Okay, now what are class properties and methods? So you can see that this functions which are there inside, we already many times we were calling them methods. So these are called methods, and properties are this sort of attributes which are like non-method fields, right? They are called properties. Now you can see two things, that mm, you can initialize it like this also, or you can initialize it like this also. The thing is that let's say you simply write something like this. Let's say width is equal to 0. If you remember just before, if we did something like this, then this width was undefined, right? You can see that this width was undefined, but we could have created something like this also, right? So in this case it was 0, and further if this thing was also there, then it would be initialized 5. So you can understand that this is also one way of creating. But even if you did not create it like this, but you directly inside constructor you did something like this dot any that whatever property name is equal to something, then even if that property was not there, then this property will be created. Okay, and if already it was there, then it's fine. But if it was not there, it is created, and if it is already there, then that value will be overwritten in if the constructor is called. Okay, so so that is a property. This thing is also called an attribute. So property and attribute, many times they are used interchangeably. The thing is that generally if it is used in the context of property is a generic concept which is used in case of classes, but in case of static, if classes is static or something, then the meaning can be slight nuanced, but most of the cases they will be like used interchangeably. We'll see that what are static fields and all in a couple of slides. Okay, so right now you can see that yeah, so this we already saw that s dot width would be, in this case, will be 5 because the constructor is called, right? And and this thing is going to be 25. That's fine. Now class properties and methods are also called class members. So simply if class member somebody is saying, then that member can be a property member also, can be a method member also. Okay. Now instance properties must be defined inside of class method. So whatever the properties we are seeing here, they are available on instances as we saw earlier, right? Later we'll see that there are some properties which are static in nature, which means that they are not available on instances, rather they are available directly on the classes, and they cannot be accessed from instances, they can only be accessed via class names. So that we are going to learn soon. Now class fields. So class fields is actually just class fields is just you can understand that these attributes, these properties which we are discussing, they are also called fields or public fields. Later we will also see that there are ways of making them private, and in that case they are called private class fields. But right now you can understand that attributes are property, fields, these words you can use interchangeably. So the 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 field what we are talking about, so this thing like height is a field, width is a field. Now you can see that yeah, means obviously they can be initialized inside the constructor, even if you don't initialize it here, then also you can initialize it after. So it's just that let's say you initialize two things here, and then only one of them you reset in constructor, then other one. So it's like just a safe thing to do. Moreover, let's say inside the function and then inside another function, that function is called something else. So it's like that you are not writing it everything at one place, right? So for better readability, it's a good practice to have all the fields at one place, right? So that will give you a proper thing that what are the various fields which we are using in this class. So that is one thing. You might think that yeah, this is immediately going to be overwritten in this constructor, so why to do this? So that is just that is just it is what we discussed, that width is equal to 0 is never going to be, if you're calling it like that, then immediately it is going to be set by 5, right? But then the idea is that if let's say this thing is not done here, not reset, then obviously this thing will be 0. At the same time, you don't need to initialize it, you can simply write like that, and that is also fine. Okay, and in that case it will be undefined, right? But you can say that if this is not there, then this will be not even defined. Okay, this in this case at least it will be defined with a value called undefined. Okay, and more so if you want to set something, then it's better. But the main thing you have to remember is that we are not using any let or const keyword here, right? Inside classes, when you declare these fields or properties, then you don't use those keywords for declaring it. Okay, now this thing is straightforward, right? The field can be declared with or without default value. We just saw that you can write a default value, you may not write a default value, then in that case it will be undefined. So you like something like this, and we saw that all together we the main thing, you can see that if we remove constructor altogether, then we can see that yeah, if you create a class rectangle, then obviously these things will be ignored because there is no constructor, and then if you try to print width and height, it will be low, those values, whatever the default values are there. Default value was 0 0, it was not, there was no default value, then it will be undefined, right? And we just saw that we don't need keywords like let, const or var here inside class. When you are declaring properties of fields, you don't write any let, const or the such keyword. Okay, now why are we doing this? So as we discussed earlier, that the purpose of this thing is just slight more clarity. We don't want to dynamically generate it, like you can understand, right? So not only this is sufficient, let's say you did something like this. Let's say foo, some function is there, you have some function here foo, and inside that you do something like this. and inside this you call width, inside this let's say you call width. I'm just giving an example, nothing much. So yeah, so it will be this dot foo anyways. So you can see that this works, right? This also works. Now you can understand that the actual assignment of width is inside constructor we call another function foo, and actually inside foo again this can be again somewhere else some other function is called an internal. So dynamically when constructor is called, when this thing is being assigned and created, whenever this thing is assigned, then if this thing was not already there, then it is created, right? But then it is a good practice that at the top we can have something like this, right? That what are the various fields available, and that will give us more clarity. So if we are declaring fields upfront, class definitions just become more clear, and the fields are always present, which means that whether fortunately or unfortunately you miss this function call or not, doesn't matter, this thing is always defined. It will never give you an undefined or something. Okay, so that and those are the advantages of declaring fields upfront using this syntax. Okay, now yeah, so we just saw this that this is straightforward, where width and height, rather than one argument, you can have multiple arguments also, and they can be available, right? But this is the normal case. Right now there are scenarios where the fields are not public, rather they are private. Okay, now what is the meaning of private? Now you can see that if we are having some, so let's make this simpler for now. Okay, let's make this simpler for now. And now you see that you can access s dot area, that is fine, but you can also access width. You can also access width directly. Okay, what if I just want you to access area, and if you want to get width, then have another function get width or something, but I don't want to allow you to get directly directly this attribute width. So right now you can see that it is public, and that's why it is being accessible. In fact, whatever property you create, by default it is public. If you want to make it private, then there is a syntax for it. You put a hash in front of it, and then everything works as it is, which means that wherever you are using this dot width, you just make it like this, which means that if you just now comment it, then you can see that earlier also it was 25, now also it's 25. It's working perfectly fine as earlier, but now obviously there is nothing called width, but there is hash width. This thing, if you try to access, then you can see that you cannot access it directly. Okay, however, you can do something like this, that yeah, you can declare your own function get width, something like this, and then in that you can get this dot width. Okay, so something like this, not hash get width, simply get width. So you can see that now you can get the width, but you cannot directly access this, because width cannot be accessed directly, because this is now private, and this is the way in which it has to be declared. And again, like normal attributes, it can also be assigned or not assigned with a default value, and the rest everything is almost same. Okay. Okay, and then again, just I give an example of get widths, that private fields can only be read and written by class body. If you want to somehow get something like this, then you need to write some custom functions in order to do that. Okay. Okay, or I think you can write getters also, which we'll see later, that let's say hash width is there, but there is no width name, so I can use that width, and I can do that dot get, and then now obviously hash width will not be available, but I think s dot width should be available, because now the s dot width is just a getter which in turn returns this. Okay, and that is fine. Okay, so this will give you error, but this will not give you error, or for that matter, even if you create a getter, then simply like this will also not give you an error. Now private fields can only be declared upfront in field declaration. This is a difference in private field with respect to the public field. We saw that in case of public field, this was optional. That, like, even if you did not do that, for the first time when it was being assigned, it was automatically created. But it turns out that in this case, it will give you error. Right? If you are using a private field, then if that private field must be properly firstly declared also, and then only it can be used. Private fields cannot be created later through assigning to them, the way normal properties can be, which we saw. So yeah, the same example, something like this is compulsory. If this is not there, then you will get an error. The static keyword defines a static method. Now, earlier we were discussing, we took this name a couple of times, right? Static methods and static properties. Now let's go deeper into it. Static means that that thing is only available on the class itself, not the instances. Okay, so what does that mean? It means that the static members are called without instantiating their class, because that is a feature of the class itself rather than its instantiated object. Okay, and moreover, it's not that it should be called on the class, it just cannot be called on the instance. It cannot be called through the class instance. Okay, now static methods are, no, what is the purpose if I am not creating an instance? If I'm not creating, so this class is there, right, and I'm not creating an instance, so what is the purpose? So for example, let's make the example slightly simpler. So let's make it this only, and this should be fine. Okay, and now you might be thinking that, yeah, until unless, so if you have something like this, so let's say sum foo is equal to hello. Yeah, but this if you do something like this, then this is a normal property, which means that it is not a static property. For static property, you have to use static keyword, which we will discuss, right? So for example, in this case, you can see that until unless you do something like s dot foo, then only you can access it. S dot foo is hello, right? But and if you try to do something like directly square dot foo, then it will give you error. Error means that that thing is not available. Okay, but if you use a keyword called static in front of it, which means that now this property is a static property, which means that it can be directly accessed in the class name dot foo. Okay, and then it can be accessed directly. Okay, and not only that, if you try to access it on instance, then you cannot access it. You can see that you're not getting it. So it is mandatory for static methods, static properties or static methods, anything, to be called directly on the class name only. Okay, now now this thing is fine, but what is the purpose? Why would we ever want to do that? Turns out that let's say you're just writing some configuration. So let's say you're just saying that some data you want to save, that yeah, some language is English, and this is internal to the class, and or some other things, some data you want to store inside the class, but in that sense, that is common to all common to all the instances, right? You understand? So let's say I can clearly say that what is the lang. So you can see that language is English, right? But let's say you are creating a multiple classes. So let's say S1, S2, S3, not classes, multiple objects you are creating, right? So S1 dot width, you can see that this is 5, this is let's say 10, this is let's say 15 or whatever. Now you can see that S1, S2, S3 is there, and then it is printing everything, right? But you can see that this width for each of them is each of the instances, it is taking separate memory location, because 5, 10, 15 all are different, so they need different variables to be stored, and that's why in each instance the instance variables take separate spaces. But that is not the case for static. What happens that in fact, using instance variables you cannot access lang. Moreover, square directly on class you can access this, and because of that this lang is shared among all the classes, which means that you don't this thing is not created every time you create a new object. This thing is not created. This thing is just created once for the class itself, and after that for every creation of the object only the normal attributes are normal properties are actually instantiated. Static properties are not instantiated. Okay, so that saves us some memory space, right? And right now I'm just writing en, but you can understand that this can be a big, let's say JSON, some configuration file or something. So I don't want to duplicate that to avoid too much using memory or something, right? So that can be helpful in those cases. So yeah, static methods can be used for some creating some utility function. So for example, let's say I have a square this thing, right? Then let's say somebody says that yeah, area you are giving me fine, but can you give me a length of the diagonal? So let's say I create a function called diagonal length or something, right? But you know what, this thing is just a utility function, which means that I pass it whatever the side is there, one side which is the width in this case, whatever side is there, and I just return square root of 2 into that side. Okay, so let's say math dot sqrt, we know that we know that root 2 into a side is the length, right? So this thing I return. Now why do I now this thing is just a utility means that you can understand that yeah, so so let's say this thing is right now width I'm getting, but let's say right now I want to get diagonal length, and width I want to pass, because because what I want to do is that this is a utility function, right? So let's say for 5, for 10, s1, s2, so s1 dot width is there, s2 dot width is there. For each one of them I want to separately get the thing. So why to make it on instead? So this logic is same, right? This logic is same. So why to duplicate this logic? You understand? If I make it like this, if I make it like this, then every time I instantiate, this function is created again and again and again, and like the same logic is repeated every time for each instance. Why to do that? Why can't I do something like this? I can make it static, and now I can directly use something like this. Directly on the class, I can use square dot diag length, and then side, whatever the side I want. So s1 dot, so for this square I want to find the diagonal, then I'll get this. For s2 I want to find, I'll get this. As simple as that. And in that manner you can see that I can get 510, which is the obviously the width, and then I can get the diagonal length pretty simply, right? So this solves the problem of repeating this logic again and again. Now every time you create hundreds of instances, you create objects, you create, but this logic is shared among all of them. This is sort of a utility function, right? So that's what it is mentioned here, that it can be, static methods can be used to create utility functions for an application, and properties can be used for having some configuration file, having some caches that doesn't need to replicate it, that doesn't need to be again and again duplicated or replicated across instances, and one configuration or something is there. So for that, static thing can be there, right? So it is your you just understand that static is class basis, just once per class, and normal properties are non-static ones are instance specific, right? Now once you understand that how to use that yourself, then you can decide, you can be a better judge of yourself when you need what. Okay, now you can see that if I have something like this, then directly I can do square dot foo, directly I can do square dot greet, because these are static. So this is the way to do it, static keyword. Okay, and if you create instance and then try to do on instance dot foo or something, then you will not get it. We saw it, right? Because this is static, it can only be accessed via class name dot, not instance dot. You will get undefined in that case. Now there is something called static initialization block. So whatever we are doing here, so let's say we are doing, you can see that yeah, you can see that we are doing static here, static here. So the thing is that you can do something like this also. You can have a static block, and inside that you can do something like this dot lang, right? This stat lang. So what is the purpose? The purpose is that now, so this is just it is also static, which means that even if you are using this dot lang, actually this is like this is just a static thing, which means that still it will be accessed like square dot lang, not instance dot lang, right? So you can see that square dot lang, and when I try to print it, then en is printed. So you can understand that this is a special syntax where static space and then curly braces is there, and in this block whatever you write, that is, there is not instance specific, that is still part of the class only, but that is only executed once, and in this block you can write your, do your own logic. So let's say const some mathematical calculations you are doing, and at the end you are like using that to something to create that. So if you need some logic, slight logic, you understand now that directly if you write try to do let's say this dot lang directly, if you simply assign a static lang is equal to or for that matter anything, then we are not going to use we are not since this is not a full-fledged block, so we don't have much flexibility to do a lot of things, right? But right now, since this is a full-fledged block, then here you can create new variables, call new functions, get the output, and is essentially at the end whatever you are getting, that you can assign it here, right? So yeah, this is just a additional thing if you want to know it. This is called static initialization block. It enables more flexible initialization of static properties, nothing much. Okay, it allows initializations. For example, right now you're worried that this might throw error, so you can rather put some try catch, this thing inside try catch. Okay, so as you can understand that this is giving you like more power in that sense, nothing much. Apart from that, you can also set multiple fields in a single value, which means that you can have multiple fields in one value. So I can I can have this dot lang, or the, let's say this dot config, right? And again let's say something called let's say name, square, I don't know, like anything you can put. But the idea is that it's not that only one name you can have multiple names also, right? So let's put a different name. So let's say title or something, my square, something. And the same thing you can have now dot title, and you will get the my square. So multiple things also can be done. Not only that, in fact, you can have multiple static blocks also. Okay, you can have multiple static blocks also, and in that you can do something else. So let's say, I don't know, title 2 is equal to my square 2, just a new variable created just to test it. So let's say title 2, and now you can see that this thing is also working. And you could have written it everything in one static block. You could use multiple static initialization blocks. In fact, I think that you don't need this, because this also I think you can create here something like this, isn't it? Okay, so if let's see if some syntax error is there, because I did some mistake. Let me see. Class block is declared. Is it fine? Okay, so looks like fine. Yeah, so let's see. Yeah, so let's see. Now if I try to get diagonal length, so let's say I want to simply get square dot diag length of s1 dot width. Okay, then you can see that I can get the answer, and which means that earlier or however it was working, that is working fine. And now instead of 2 blocks you can have 1 block also, so that is fine. So now you have understood, right? You can use anyway, like inside one you can use multiple, static blocks, all those things are fine. So yeah, this is what we were discussing. Static. This syntax we already saw, but this is the new syntax. Inside curly braces also you can use whatever. And in this case, this is not instance. This is just like it is just a syntax, but actually still it is like this has to be invoked on particular class only. It's not class instance. It's just class, which means that later if you want to use it, then you have to use square dot bars. Okay, this is not an instance, this is still simple class. Okay, and we saw an example of getter. Also you can use setters also for that matter, and yeah, so whatever in normal functions, however the behavior is there, that you can do here also. s.area is simply a getter, so it will return the calc area. In this case, calc area in this case will be 5 square 25. So yeah, even though there is no property called s.area, but there is a getter called s.area, which will essentially behave like that only. And this was a normal getter. In fact, there can be a static getter also. So like static attributes can be there, static functions can be there. Similarly, static getter can also be there, which means that instead of get area, you will have static get area. Static get area, right? And again, here you cannot use instance variables. Right? Because that will be undefined. You can only use variables which are again static in nature, right? So if another static variable is there, then that you can use, and that will be accessed like this dot width. Okay, so yeah, so what will happen if you simply create simply square dot area, then square dot area is going to be 100, right? Because I know that square dot width is also statically defined, right? 10 already hard coded, right? Then square dot area is a getter which will be essentially 10 square, so 100. So yeah, that is an example of a way in which the getters can also be static. Okay. Now there is a concept of this within a class, and this concept is almost similar to what we saw earlier for functions, with the only exception that the rule which we earlier saw, that like modules, the classes body, also the whole code inside the class body, runs in strict mode. That is the only difference. Apart from that, everything is same. Okay. Which means that if there is a class something like this, then if you return this, then this is a normal member. This is a normal method, right? So it would be definitely called on this instance, and that's why this in this case is actually the instance. You understand? So this is what I'm trying to say, that when you do p dot foo, which means that this inside your function foo must be p. And what is p? P is the instance, the created instance. In fact, later you can see that p dot foo and p, if you compare, then you will see that true, which means that whatever I'm claiming, that is true. Second thing is that if you want to call the static property, so something like here is static bar, how you will call it? You will call it class name dot bar, and if you call that, then this will not be an instance, because it cannot be an instance, it's just a static variable, right? So this thing, if you run, then this will be simply class. So you will see that class person is there. And if you want to prove that what I'm saying is correct, obviously you've seen it, but you can compare this with simply person variable, not the instance, simply person, and you will get the true. You will get true, which means that that is true. We are getting this reference to the normal basic class only. Okay, so that is one thing. But if you try to do something like this, that if you assign p dot foo to a separate variable and then call foo, rather than calling p dot foo directly, if you simply assign this to another variable and then call, and then this we saw earlier also, right? Then if we do something like this, then this thing is called in global context, right? And in global context, it is returning undefined. This is returning undefined. Why? Because class runs in a strict mode. We saw that in a strict mode, if something is called in global context like this, then this is then the function also used to return undefined, and right, that's why this also returns undefined, because class, whether here or here, everything runs in strict mode, and that's why this is undefined. Now we saw a bit of class syntax, but the whole thing is that these are sort of internally built on top of functions only, internally. So if I have a class like this which has foo and static bar, foo is a non-static attribute, non-static method, and this is simply a static function available on this class. If that is the case, then you can see that this thing can be simulated using functions like this. What you can do, you can simply create a function, let's say person. Instead of class person, you write function parents like this, and then whatever is like the static thing, you can directly declare it on that class itself. Why? Because that is how it has to be accessed, right? Directly on that class dot, it has to be accessed. But those which are non-static things, they are accessed on instances. And when we were earlier discussing about prototype, we saw that whenever we discuss instances, then that has to be on prototype. So if you write person.prototype.foo is equal to this thing, then this foo cannot be accessed directly like person.foo. But if you create a new object like new person, something like that, you create a new object, then on that object foo will be available. and that is the advantage of declaring something dot prototype dot that thing. Okay, now when we were learning about modules, CommonJS and something, we discussed that like variables, constant, functions, all these are exported and imported. Similarly, classes can be also exported and imported, right? And that time we did not learn classes. Right now we are learning classes. So let's just quickly recap that syntax, that how to export classes. Okay, in CommonJS syntax, module.exports is equal to, like earlier we used to do module.exports is equal to 10, or module.exports is equal to hello, or module.exports is equal to function something, right? Similarly, you can simply do module.exports is equal to some class name, and that will also work fine. Okay, and in case of named export, you can do something like that, this also, that let's say whatever name you want to give. So in this case it will be default, sort of, not default, because in CommonJS there is no concept of default, but you can understand that it will be available, like if webpack or something is there, then that will be using it, that will be using it accordingly, right? With default keyword. Okay, but if you want a named variable also, then that can also be accessed, that can also be exported like this, where this thing is going to be class and then anything, and again here name is not needed. Here also I think name is not needed, but yeah, you can try it on your own. The thing is that whatever the first name we are bounding to, that will be dot name of that class, and here also the named variable which is exported, that is also square here. Okay, in case of ES modules, the syntax is slightly like the syntax is slightly different, which is like export default and export class. So earlier we had like export default and anything, right? So in case of functions, we had export default and then function keyword, and then after that you can write that function, right? In this case, export default class and something like this thing will work. And if you want to use simply named export in case of ES modules, then you can do something like export class square. In this case, this class is default exported, which means that when you are importing, you can use any name. In this case, it is a named export, which means that export class square, which means that a variable named square is exported. Okay, and it is bound to the name square, and that's why it's called named variable, named export, sorry. Okay, so that is how you can use classes also for exporting when you are using modules, whether it is CommonJS modules or ES modules in JavaScript system. Okay, so that will be all for now. So definitely some more concepts like inheritance, subclassing, these things are still not covered, but slowly and slowly we will cover those also for JavaScript. But now you are in good shape to understand the basic semantics of classes in JavaScript.